All right, good evening, children.
Good evening.
Good evening, ma'am.
Good evening, ma'am.
Good evening. Good evening.
Good
Yeah.
evening, ma'am.
Good evening, children. Good evening. Please write down this. Statistics is a branch of mathematics.
Good evening, ma'am.
Good evening.
I went out with my mom, so I couldn't join the meeting on time, ma'am.
All right, Madhumita. One minute. Before this, after statistics, write data first, okay? After statistics, please write data and then raw data. Yes, children. I hope you wrote the definition of statistics first. After statistics, write this and then you can come to raw data. Now you have to tell me which slide I have to show. This one or this one?
Ma'am, statistics.
Okay. You're done writing?
Yes, ma'am.
Yes, ma'am.
All right, yeah. Now raw data.
Ma'am, can you please show the previous slide for a second?
Yeah.
Thank you, ma'am.
Done writing, children?
Yes, ma'am.
Yeah.
1 minute.
Okay.
Completed like that.
Yeah. Sorry, 1 minute. I always get confused with spelling of discontinuous, children. Just check if I'm writing it correctly. Discontinuous, discontinuous. Just check my spelling. I'm really not sure. Discontinuous. What is FD, children? What is FD? Frequency distribution. We are using it in the class. It's not, you should write frequency distribution fully in your test or exam. Now, just to save time, you can just write FD. Frequency distribution table. Finished writing, children? Please let me know. I'll not keep disturbing you. Once you finish, let me know. Does it take this long to write, children?
Completed, ma'am.
Completed, ma'am.
Okay. So all this I'll explain when we take up the, when we are now about to take up the questions which you have written out already. So all this will be explained there. So the terms we have seen so far are statistics, data, raw data, frequency distribution table, ungrouped frequency distribution table, grouped frequency distribution table, primary data, secondary data, bar graphs, histograms, continuous class intervals, discontinuous class intervals. Continuous class intervals are also called exclusive class intervals. Discontinuous class intervals are also called inclusive class intervals, or they're also called class intervals of inclusive type. Inclusive type class intervals, exclusive type class intervals. Okay, I can include that word type. Inclusive type class intervals, exclusive type class intervals. All right, children?
Yes, ma'am.
Yes, ma'am.
Okay. No, I don't expect you to remember everything now. All this. As we do the sums, these terms will get registered by itself. Now let's take up the first question.
Completed, ma'am.
Yeah. Now look at the first question, children. The following data gives the number of children in 20 families. So a statistician has visited 20 families. A statistician has visited 20 families and collected the data regarding the number of children in each family. A statistician has visited 20 families, maybe 20 random families or 20 families in a particular locality, whatever. So a statistician has visited 20 families, and what has he done? He's collected the information regarding the number of children in each family. So since he has visited 20 families, there are 20 numbers there. 5, 2, 3, 3, 1, and so on till the last ones are 2 and 3. So there are 20 numbers. What does the first number tell you? 5. So there is one family which has 5 children. The second number is 2. So there is another family which has 2 children. The third number is 3. So there is another family which has 3 children. Another family which has 3 children. Another family with 1 child. Another family with 2 children, and so on. Do we understand what the numbers in the data represent? Yes, no.
Yes, ma'am.
Yes, ma'am.
Yeah, I want Raja's voice to be the loudest.
Yes,
Okay.
ma'am.
Yeah. So the numbers represent the number of children in each family among 20 families. So now these numbers are called data because it's the information collected by the statistician, and you can also call it primary data. If the statistician has visited the families, if he has visited every family and asked the head of the family or the mother regarding the number of children they have, then that data is called primary data. Why is it primary? Because the statistician has himself visited the 20 families. He's not got this data from somebody. He has personally visited the 20 families and asked the parents about the number of children they have. So this information is collected directly from the source. So this is called raw data. This raw data is called primary data. It's raw data because it's raw, meaning it is not ready for analysis. Now, what does a statistician do with the data? He analyzes that. He first, puts the data in the form of a table. That is, he organizes the data. And then he analyzes and interprets the data. So now this is called raw data because it's not still ready for analyzing. For that, the statistician has to put this data in the form of a table. So it's called raw data, like you say raw rice, because it's not ready to eat. Why do you say raw rice? Because you have to cook it before you eat it. Well, you can eat a raw mango. That's a different thing. But when we say raw rice, it's raw rice because it's not ready to consume. It's not ready to eat. You need to cook it before you eat it. Similarly, raw data, meaning data which is there with you, but it's not ready for analysis. You cannot analyze anything from that data because it's raw data. You need to put the data in the form of a table in order to analyze it conveniently. So this is raw data, and this data is called primary data if the statistician himself has visited the 20 families and collected the details about the number of children from them. If supposing he did not visit the 20 families, he just went to some government office. Say he just visited a government office and he picked the data. He picked the data, from the records there. Then that data is secondary data because he did not collect it himself. Maybe the family which has 5 children has 6 children now. Maybe. Or say the family which had 1 child may now have 4 children. Because the data which is already collected and is present in the government office or wherever may be old, may have been collected some years ago, and that data may not be correct as of today. So if the statistician visits some, say hospital or some government office to collect information which is already stored there, they had collected, the hospital authorities or the government office, they had collected the information from, these 20 families for some reason earlier in the past. Now, maybe it's 2 years or 3 years down the lane. And the statistician, he takes the data which is already stored in the hospital. So then the data is called secondary data because he is not directly collected it from the 20 families. And that data may not be accurate also. As I told you, the family which had 1 child may now have 4 children. So you cannot say. So when it is secondary data, the data may not be accurate. That is a disadvantage. When it's secondary data, the data may not be accurate. Primary data, the data is accurate because you have visited the 20 families and it's fresh information. Primary data is more accurate. Secondary data may not be accurate. Okay, if there has not been any change, then it is accurate, but you cannot say that. So secondary data may not be accurate. Now take this, when it is about the weights of 20 children. If you actually if the statistician actually meets the 20 children and makes them stand on the weighing scale and records their weight, then that is accurate. That's it. That's the information today. So that's primary data. And it is accurate, it's reliable because the statistician has performed it himself. But supposing he visits the school, where those 20 children study, he visits the school and the school has records about the heights and weights of children, right? So supposing he visits the school, or maybe if it's a village, he visits the panchayat office where, the Panchayat Raj has the details about the number of people living in the village, whatever, height, weight and all that. Supposing he visits the Panchayat's office and from there he just picks the weights of the 20 children he wanted. So those children may have put on weight now. Or maybe a child who was obese has reduced weight. So when he picks the weights from the panchayat's office where the data is already stored, that is secondary data, and that data is not reliable. It may not be accurate. So that's the difference between primary and secondary data. And data is the information collected by the statistician. Is it fine, children? Raw data,
Yes.
primary data, secondary data. Primary data, reliable, very accurate. Secondary data may not be accurate, so it's not reliable. Got that?
Yes, ma'am.
Yes, ma'am. Yes,
Yeah.
ma'am.
Very nice. Now, what does the statistician do after collecting data? He has collected the data to perform some study. So what he does is with the data, he wants to, now see, supposing it is about some 10,000 children, he has 10,000 numbers in front of him. It's so difficult to analyze the data. So he has to organize the data. The statistician, supposing he has 10,000 numbers in front of him, he's personally collected the weights of 10,000 children of a particular locality. Then he has 10,000 numbers in front of him. There is a number 35, 65, 110, 15, so on and so forth, like that. So it's so difficult to analyze the data. So what he does is, the statistician, after collecting the data, which is called raw data, he organizes the data. Like when you do some project work, you write out so many things in your A4 sheets, you stick pictures and that and this, and then you arrange the sheets, right? After writing, you arrange it, then probably you spiral bind it before you actually present it to your teacher at school. You do so many other things. So like that, the statistician, before he comes to conclusions, he has to arrange the raw data, or he has to organize the raw data. So that is what is the definition of statistics. It's a branch of mathematics that deals with the collection of data. The statistician has to first collect the data, then organize the data using tables. Tables, there are two types of tables. Ungrouped frequency distribution table, grouped frequency distribution table. Collection of data, that is raw data. Raw data can be primary data or secondary data. Collection of data. Data can be raw data. Sorry, data is raw data. And that raw data can be, so data, raw data, both are like the same. So there's no raw data is because you cannot analyze that now. You have to organize it and then only it's ready for analysis. Raw data. Okay. So data is of two types. Primary data, secondary data. You understand what they are, what the difference is between the two. Primary data is reliable because it's accurate. Secondary data is not so reliable because it's not so accurate. It is subject to changes. It was recorded 2 years ago. Now we do not know if that is still a fact. Like that. So that is about data, primary data, secondary data. Then come to organizing the data. The statistician can organize the data in the form of tables, frequency distribution tables. And he can decide whether he needs to arrange it in the form of an ungrouped frequency distribution table or a grouped frequency distribution table. So ungrouped is preferred when the data is small in size. When the data is small and very small in size, like 20 children, sometimes you may not need a grouped table, a grouped frequency distribution. So mostly we use a grouped, ungrouped. We use an ungrouped frequency distribution table when the data size is very small, or when the data does not involve numbers. when the data does not involve numbers. Supposing the statistician collects information about the blood group of some 500 people living in a particular locality. Supposing the statistician collects information regarding the blood group of some 500 people living in a particular locality, then he cannot use class intervals, meaning he cannot use grouped frequency table. He has to use an ungrouped frequency table. Because blood types we have O positive, okay, simply O, then A, B and AB. Broadly we have these O, A, B and AB. So these are the only 4 things. But if it's numbers, and supposing it is about the ages or weights, there's a lot of variation. So then he can use the grouped frequency distribution table. Like he can use class intervals like 0 to 10, 10 to 20, 20 to 30, 30 to 40, 40 to 50. But whereas when it's about the blood group, there is no choice. You have to make 4 things, which is O, A, B and AB. And you will have to write the numbers against each blood group. So that is organization. Organizing the raw data using tables, frequency distribution tables. The frequency distribution table can be ungrouped or grouped, depending on the nature of the data collected. If the data involves numerical values, then you can do grouped or ungrouped, depending on the size of the data. But if the data is about, blood group or, which color, some 100 children, and it's about the color, their favorite color. So one says red, one says blue, one says pink, one says brown. So here again, you cannot use a red to blue, blue to green, green to yellow. No, you cannot make class intervals like that. So then the information is about the colors children like. So then you just have to write red, blue, green, yellow, black, pink, and you just have to list the colors. You cannot use a class interval. So depending on the nature of the data collected, you have to decide, or the statistician will decide if it will fit into a grouped table or an ungrouped table. So once the table is ready, once the statistician presents the data in the form of a table, it's ready for analysis. Now what to analyze? Depending on why he has collected the data. When the statistician collects the data, he had some reason to collect the data. Why did he collect the data regarding the blood groups of different children? So there was some reason for that. So that is analysis. Analysis depends, or analysis is about the reason why the data was collected. So if it's about the weights of students, so maybe he wants to decide if the student fraternity now is more to the obese side, or more to the thinner side. So whatever the reason was for the statistician to collect the data. So analysis, then interpretation, then giving the results. Interpretation is giving the results. So announcing that most children of this particular school are obese, or most children of this particular school are healthy. So giving your interpreting the data. So this order is very important. You cannot change the order. Statistics is a branch of mathematics that deals with the collection, organization, analysis, and interpretation of data. So collection can be collection of data can be primary data or secondary data. Organization can be ungrouped frequency distribution table or grouped frequency distribution table. And if it is grouped, the class intervals can be of the inclusive type or the exclusive type. If it is a grouped frequency table, then the class intervals can be of 2 types. Discontinuous, continuous. Discontinuous class intervals meaning inclusive class intervals. Continuous class intervals meaning exclusive class intervals. So that's about organization, analysis, studying the data to come to conclusions, and interpretation. Interpretation is normally, given using some statistic terms or in statistical language. So in statistics, we have various, ways in which you can interpret the data. And among that, what we are going to study now is about the measures of central tendency, mean, median, and mode. That's all we are going to study. There are many other things like correlation, standard deviation. There are many other things. Data can be analyzed and interpreted using different values, like the value of standard deviation or the correlation. There are so many other things. But what we will be studying is the measures of central tendency, mean, median, and mode. So here for us, the statistician will give his interpretation in the form of by announcing the value of mean, or by announcing the value of median, or by announcing the value of mode. So in our syllabus, we will be analyzing and interpreting the data using mean, median, and mode. We will analyze using the statistical standards, and interpretation is given in the form of mean, median, or mode, values of mean, median, or mode. So that is what is statistics all about in very simple language for 9th standard. Do we understand, children?
Yes, ma'am.
Yes, ma'am.
All right. So that covers all the terms which I have written here. Yes. So now coming back to this question, 20 families, 20 numbers. Each number represents the number of children in that particular family. Now the question is to prepare a frequency table. So the statistician has collected this information. He wants us to put this in the form of a table. So he wants us to organize the data. It's raw data. The statistician wants us to organize the data, and he says, please put a frequency table for me and let the frequency table be ungrouped. So he does not ungrouped, meaning what is ungrouped? Okay, I didn't tell you what is ungrouped. So grouped meaning you should use class intervals. Ungrouped meaning he doesn't want you to use class intervals. I don't know if I wrote that. I'm sorry, let me write it now. I don't know because that slide I've erased. So if it is ungrouped does not involve class intervals. Ungrouped does not involve class intervals. Grouped involves class intervals. Grouped involves class intervals. Please write this also, children. I don't know if I mentioned this. If it's not there, please make a note of this.
Written, ma'am.
Yeah. All right, children. So now we are going to help the statistician put up a ungrouped frequency table. So the solution for the first one will be something like this. Now the different numbers in this raw data or data are 1, 2, 3, 4, and 5. There is no family with no children. There can be, but here of the 20 families, there is no family with no children. Every family has at least one child. Every family has at least one child. So the heading is very, like logical or, very reasonable. Number of children. Number of children. And the second heading is number of families. Number of families. Number of children. 1, 2, 3, 4, or 5. See, these are the answers given by the, the mother or father in the 20 families. The answers are what? That's what I've written here. I've written the answers here. The answer was either 1 or 2 or 3 or 4 or 5. Now start using tally marks. Use tally marks Okay, now 5. See here, against 5. Now I want all of you to look at the screen. Look at your screen. I know you all know this well. Still, I want you to listen to me. See, the first number is 5. So I put a tally mark against 5. Okay. First, so I put a tally mark against 5. Then 2. Tally mark against 2. 3. A tally mark against 3. Again 3. So another tally mark. Then 1. So here. Then 2, 2. So 2, 2. Then 4, 2, 5. 4, 2, 5. 4, 1, 1. 4, 1, 1. 2, 3, 4. 2, 3, 4. So you know when there are already four tally marks, for the fifth one you should just slash, and this bundle is a bundle of 5. 1, 2, 3, 4 and a slash. So this means 5. 1, 2, 3, 4. You should not put the fifth line like this. The fifth line should go across like this. Okay. So where did I stop? 3, 5, 8, 11, 14, 15, 16. I think I have the last 4 numbers. 1, 1, 2, 3. 1, 1, 2, 3. 2, 3. Understood, children? How to use the tally marks? Yes, Raja?
Yes, ma'am.
Very good. Now tell me the number of families, Raja.
Ma'am, 5,
5.
6,
Yeah.
4, 3, and
What should be the total?
20, ma'am.
20. 20 should be the total. So this, children, you should put it in the form of a table. Okay, so like this it should be neatly put in the form of a table, children. Don't show these extra lines like this, or this is not there. These extra lines, sorry. Okay, like this. This is a ungrouped. Okay, and the frequency table should always have a heading. Should always have a heading. If I do forget to write the heading, you should remind me. So this is a frequency distribution table showing the number of children, in 20 families. In 20 families. A table always has a heading. I told you if I forget also, you should tell me that I have forgotten to write. Frequency distribution table, or you can write simply table showing, okay, showing the number of children in 20 families. So now we have helped the statistician to organize the data. So how many families have the least number of children? Quick.
2, ma'am. Sorry,
Very
ma'am, 5,
good.
ma'am.
How many families have the least number of children?
5, ma'am.
No, how many families?
2, ma'am.
2, ma'am.
2, ma'am.
How many families have the least number of children?
2 families, ma'am.
2 families.
See, somebody might have given the correct answer. I'll keep asking. You should stick with your answer. How many families have the least number of children?
5, ma'am.
2, ma'am.
2 families, ma'am.
Okay, which is the least number of children?
1, ma'am.
1. And how many families?
5, ma'am.
5. That's how we can go wrong in statistics. This is exactly how we can go wrong. We feel statistics is a simple subject, but actually it is not. It's one of the most difficult branch of mathematics. Meaning difficult, meaning, yeah, sort of what we have is very easy to understand. But statistics as a subject completely is really, yeah, you need to really, oh, yeah, it is difficult. I should admit that it is difficult to understand. But the part of statistics we have for our syllabus is very easy. Yes. So my question was, how many families have the least number of children? Least number of children meaning 1 is the least number of children meaning 1. How many families? 5 families. How many families have the maximum number of children?
2, ma'am.
2. There are 2 families with 5 children each. So maximum number of children is 5. How many children maximum the family can have here? 5. And how many families? Number of families is 2. Number of children is 5. Number of families is 2. How many families is the question? How many families? 5 families, 6 families, 4 families, 3 families, 2 families. So 2 families have 5 children. So 2 families have the maximum number of children. 5 families have 1 child each. So 5 families have the least number of children. Okay, so which is the highest frequency here? Number of families is the frequency. This is the information. This is the data. The data is about number of children. This one is like the X value. This is the frequency value. See, 1 child in 5 families, 2 children in 6 families. So that 1, 2, 3, 4, 5 is are the values of X. And the values of F frequency are 5, 6, 4, 3, 2. So when the question is how many families, you must select from 5, 6, 4, 3, 2, not from 1, 2, 3, 4, 5. That is number of children. Now, which is the highest, frequency here, children?
2, ma'am.
6, ma'am.
Which is the highest frequency?
Yes, ma'am. Number of children is
6,
2 and
No, see, I told class, I told you all clearly that frequency is the number of families. The data is about the number. The data is not about number of families. The data is about the number of children. So that is X. What is the data about? The data is about the number of children. So that is X. In 20 families. So that will be the frequency. X and F. Now my question is, which is the highest frequency?
6,
6.
ma'am.
6. What is the X value corresponding to 6?
2, ma'am.
2, ma'am.
That is the mode of the data. That is the mode of the data. The mode of the data is 2. The values of mean, median, and mode will always be from that X column, not from the F column. The values of mean, median, or mode will always be from the data column, X column, not the F column. Now, how to find mode for this data? Look at the highest frequency in the F column, 6. What is the X value corresponding to the highest frequency? 2. 2 is the mode of this data. Do we understand that, children?
Yes, ma'am.
Very good. All right. So the second one is a homework because you know how to do it. 0 to 2, 2 to 4. You can do it, children. I know this is not difficult. So the second one is homework. Now, one thing I have to tell you is this over? All of you finished writing this?
Yes.
Yes, ma'am.
Yes, ma'am.
All right. All right. So I'll clear the slide. Yeah. So to do the homework, we need to understand the difference between continuous and discontinuous class intervals. So now look at the class intervals 0 to 2. Or let me take a different term. So now supposing 0 to 5, 5 to 10, 10 to 15, 15 to 20, Now these are called the class intervals. Now they're class intervals because interval, you understand what an interval is, no? It's something between two things. Interval is something between two things. So now 0 to 5 is called a class interval. Class interval. 5 to 10 is another class interval. 10 to 15, 15 to 20. So here you can see 4 class intervals. Now 0 is called the lower class interval. Let me say CI for class interval, okay? Let me say CI for class interval. 0. Yeah. So 0, 5, 10 and 15. These numbers 0, 5, 10 and 15. So 0 is the lower limit or lower class limit. Lower limit or lower class limit, both are the same. Lower class limit or lower limit or lower class interval or simply lower class. So of this, the frequently used is the first three. The first three frequently used. Lower class limit or simply lower limit or lower class interval. So 0 is the lower limit of the first class interval. This is the first class interval, second class interval, third class interval, fourth class interval. These are the lower limits. These are the upper limits. Now the lower limit of the third class interval is 10. The upper limit of the third class interval is 15. So 15 is the upper class interval of this. 15 is the upper class interval of this class interval. But it is the lower class interval. Sorry, lower class limit. Sorry. I'll repeat. I think I went wrong in saying a slip of the tongue. 15 is the lower class. Oh my God. 15 is the upper class limit. 15 is the upper class limit of the third class interval. But 15 is the lower class limit of the fourth class interval. So again, this is easy to understand. So now these are class intervals. So here you can see 4 class intervals and they are continuous, meaning 0 to 5, 5 to 10, 10 to 15, 15 to 20. There is no break at all. It's continuous when you read it. 0 to 5, 5 to 10, 10 to. So the next one starts from 5, 0 to 5. So that means the upper limit here is the lower limit here. The upper limit here is the lower limit here. The upper limit of this class interval is the lower limit of the next class interval. So here the class intervals are said to be continuous. Or it's in the exclusive form. Exclusive class intervals. I'll tell you why they are exclusive class intervals. So 0 to, let me take 0 to 4, 5 to 9, 10 to 14, 15 to 19, 20 to 24. So you can see these class intervals, 0 to 4, 5 to 9, 10 to 14. So they're not continuous. When you compare that to 0 to 5, 5 to 10, 10 to 15, 15 to 20, 20 to 25. When you compare these two, it's very clear that here the class intervals are not continuous, but here the class intervals are continuous. So here the class intervals are said to be in the inclusive form. Here the class intervals are said to be in the exclusive form. Now, why exclusive? Why inclusive? Inclusive meaning including. Inclusive meaning including. Including means what? Including you, including me. Like including you, including meaning in the class interval 0 to 4, 0 is included in this class interval. 4 is also included in the same class interval. That is why the word or the term inclusive. 5 is included in this class interval. 9 is also included in this class interval. When both the lower limit and the upper limit belong to the same class interval, when both the lower limit and the upper limit belong to the same class interval, the lower limit will always belong to that class interval. It's only about the upper limit actually. It's only about the upper limit. So when the upper limit of a class interval belongs to the same class interval, then it is inclusive because included in the same class interval. Included in the same class interval. So see, if you have numbers 0, 1, 2, 3, and 4, 0 belongs to this class interval. 4 also belongs to this class interval. 1, 2, 3 also to this class interval. 5 and 9 both belong to this class interval. And all the numbers between 5 and 9. 10 and 14 belong to this class interval and all the numbers between 10 and 14. Not only 10 and 14, all the numbers between 10 and 14 also. But when you take the class intervals here, 5, the number 5, it's here and it is here. Where to put 5? Not here, here. 5 is excluded from this class interval. 5 is excluded from this class interval. That's why exclusive. 5 is included here. It's excluded from here. Actually, where does 5 belong? Where do you see 5 first? Here only you see, no? Where do you see 5 first? You see 5 here. No, but it's excluded. It's excluded from this class interval. Excluded meaning not included. So 5 is excluded. We actually see 5 first here, but no, it's excluded from that class interval. That's why exclusive class interval. See, the lower limits always belong to that class interval only. It's only about the upper limit. So the upper limit 5 is excluded from this class interval. It belongs to the next one. 5 to 10, no, 5 comes here. That's why it's called the exclusive class intervals. Where do you see 15 first? First, where do you see 15 when you come from here? 15, you see it here. No, but it's excluded from this class interval. This one does not belong to 10 to 15. 15 does not belong to 10 to 15. It's excluded from that. But then where is it included? Here it is included. It's included here in this class interval. So 15, you should put a tally mark here. For 20, you should put a tally mark here. That is why exclusive class intervals. Inclusive is when the upper limit belongs to the same class interval. Exclusive when the upper limit does not belong to that class interval, but belongs to the next class interval. Am I clear, children?
Yes.
Raja?
Yes, sir.
No, I want the loudest voice.
Yes, ma'am.
Very good. So this is about class intervals, children. So class intervals are of two types. See, when we use class intervals, we are using a grouped frequency distribution. When we don't use class intervals, we are using an ungrouped frequency distribution table. An ungrouped frequency distribution table does not involve class intervals. Grouped frequency distribution table involves class intervals. Class intervals are of two types: continuous, discontinuous. Continuous is also called exclusive class intervals. Discontinuous is also called inclusive class intervals. Now with this knowledge, we are going to try the okay, so now the second one homework is easy. 0 to 2, 2 to 4. So 2, you know now where to put 2. So second one is homework. Third one, Yeah, so in the third one is homework, but I have to tell you something. Now, in the third one, you have something like present the data in the form of a frequency distribution. F distribution is frequency distribution, children. Present the data. Class, use the emoji. Raise your hand.
Excuse me, ma'am. Ma'am,
Yeah.
ma'am, it's time to join another meeting.
Okay,
Okay.
fine. For the rest of the class, please use the recording, Raja. All right.
Yes, ma'am.
Yeah, don't forget.
Sure, ma'am.
Yeah. Thank you.
Thank you, ma'am.
Yeah. Yes, good to see you, all of you alert in the class. Very good. Thank you. Yes, children. So, what was I telling you? Okay, so I was telling you, no, I lost the flow. Okay, fine. So continuous class intervals, discontinuous class. No, it's very difficult. We know when I stop, I don't know from where to continue. Let me come back later. I'm not getting it now. So now in the third one, you'll have to present the data in the form of a frequency distribution of class size 10. So now what is class size? Very important. Very easy, but often we go wrong here in answering this question. Class size. What is class size? Class size or class width is the number of integral values a class interval holds. Class size or class width, both are the same, is the number of integral values, meaning integer values. Integral means integer values a class interval holds. Now you know that there are infinitely many numbers between 0 and 4. There are so many numbers. There are uncountable numbers between 0 and 4. But how many integers are there? How many integers are not? So how many integers does this class interval hold? See, here is the number of integral values a class interval holds. So how many integers this class interval holds? See, how many numbers are there here? That is infinite. But how many integers are here in this class interval? In 0 to 4, we know that since it is of the inclusive type, it's of the inclusive type, 0 and 4 both belong to this class interval. So this class interval holds the integers 0, 1, 2, 3, and 4. So the class size is 5. The class size is 5. Now see here, 15 to 19. See here, the class intervals here are not continuous, meaning of the inclusive type. 15 belongs to this class interval. 19 also belongs to this class interval. So the numbers, the integers in this class interval are 15, 16, 17, 18, and 19. And hence the class size is 1, 2, 3, 4, 5. The class size or the class width is 5. It's the number of integer values a class interval holds. Now coming to this one, here the class intervals are of the exclusive type. That means 5 does not belong to this class interval. 5 belongs here. So in the class interval 0 to 5, what are the values included? 0, 1, 2, 3, and 4. Only the integer values. Now children, if there is a value like 1.5, that definitely will be between 0 and 5. Now it is not that if you have the value 1.5, you cannot put it in 0 to 5. All the values 0 will belong to this class interval 0 to 5, and up to 5 all the values will belong to this class interval. But you know that it's not possible to count. all the values in this class interval. That is why class size or class width is the number of integers in that class interval. But of course, if it is not an integer, if you have a value like 3.25, it will be included in the class interval 0 to 5, but that is not class size. Class size is only about the integer values the class interval holds. So 0 to 5 has 0 in it, 1 in it, 2 in it, 3 in it, and 4 in it, and not 5. 5 does not belong to 0 to 5. 5 belongs to 5 to 10. So how many values? 1, 2, 3, 4, 5. The class size is 5. Class size is 5. Take another one, 15 to 20, 15, 16, 17, 18, 19. 20 does not belong. If you want to include 20, there should be another class interval like 20 to 25. Supposing there is a number 20, you cannot, okay, let me put 20 in this one only because there is no class interval 20 to 25. So let me put 20 here only. No, you cannot put 20 here. 20 does not belong to this class interval 15 to 20. You must create another class interval 20 to 25 only for the sake of 20 and put 20 here. So how many values? 1, 2, 3, 4, 5. So class size is 5. Class size is 5. So now it's not always possible to count like this, no? So how do you find the class size? Without actually counting, how do you find the class size? Class size for you write it in your own language, children. I'll just tell you how it is. If it is inclusive like this, like the first one, for inclusive, for inclusive class sizes, upper limit minus lower limit plus 1. But for exclusive, the class size is upper limit minus lower limit. That's all. If it is inclusive, children, please write it clearly. If it is inclusive, then the class size is upper limit minus lower limit plus 1. If it is exclusive, the class size is simply upper limit minus lower limit. So you can try it here. See, 5 minus 0, 5 is the class size. 20 minus 15, 5 is the class size. But here, 4 minus 0 is 4. But the class size is 5. 19 minus 15, it's 4. But the class size is 5. So 19 minus 15 is 4 plus 1, 5 is the class size. Am I clear, children?
Yes, ma'am.
Yes, ma'am.
Very good. Yeah, make a note of this in your, meaning you write it in your own language. For inclusive, you should subtract and add 1. For exclusive, you should just subtract, that's all. Done, children?
Yes, ma'am.
Yeah. So this is about class size. So you can see in question number 3, present the data in the form of a frequency distribution with class size 10. Now, another thing we need to understand in statistics, it goes without saying, when you have to use, a frequency distribution with class intervals, you must always prefer to use a continuous class. You must prefer to use class intervals where they are continuous. That is, you must always use the distribution of exclusive type, not inclusive. Inclusive, if you should do only if it is, specified in the question. In the question, if they ask you to take a or ask you to prepare a frequency distribution with inclusive class intervals, in the question, if it is specified that you have to prepare a frequency distribution with inclusive class intervals, or there is some information in the question which forces you to prepare an inclusive class interval, only then you should do it. So inclusive is only on demand. If nothing is mentioned, you should always prepare an exclusive. You should always prepare a frequency distribution with exclusive class intervals. That is continuous. If nothing is specified, or if no information suggests that you should prepare an inclusive type class interval, you must always use exclusive class intervals. You must prepare a frequency distribution using exclusive class intervals only. So here the class size is 10. So you must prepare a frequency distribution table with continuous class intervals, continuous meaning exclusive, with continuous class intervals of class size 10. Now this brings us to understand some other terms in statistics called range, lower value or maximum value and minimum value. At this point, it reminds me of something very memorable to me. So when I was in, second PUC, that's how it's called in Karnataka, second pre-university. So that's how it's called there. I studied, statistics, commerce, accountancy with mathematics in my first and second PUC. These were my core subjects. Of course, English. English, did I have? Yeah, no, we had Hindi also. Yes, we had English, Hindi, because now in CBSE, you do not have, in CBSE and ISE, you don't have two languages. But there in Karnataka, it was the pre-university. We call it, as I told you, the first PUC and second PUC. So there we had two languages, so English and Hindi, along with the core subjects, statistics, accountancy, commerce, and what did I say? Accounts and mathematics. Yes, and statistics. It makes me feel nice that I got the state highest in the year 94. Way back in the year 94, when I finished my second PUC, me along with another student from a different college. So both of us had got 98 for 100 in statistics, and that was the state highest. And those days we just studied. We did not study to get a rank or, nothing like that. Simply we study. So much of credit to the teachers then, because we never knew that, we had to work hard, work to get the state highest, nothing like that. All that was, we just studied like that. The teachers were so dedicated, so committed. I still remember my statistics teacher, that energy with which he used to teach the class. He made, when I started this chapter, I told you that statistics is a subject difficult to understand. And yes, it is, but he used to make it so easy for us. He used to make it so easy for us. So I owe so much of credit to that teacher. He, unfortunately, he's no more, Mr. Dinesh Prasad. We used to call him HVD. We used to call teachers by their initials. So HVD, Dinesh Prasad. So HVD, we used to call him HVD. Very nice, professor. So unfortunately, he passed away in an accident. So he used to make it so interesting, so easy. Yeah. So that is a small memory of mine from my 12th standard. So going back to this, children, the third question reminds us, the third question, to do the third question, we need to understand this term called range. What is range? And why should we use range in statistics, or why should we find range? So range is the difference between the maximum value and the minimum value in the data. Range is the difference. Range is the difference between the maximum value and minimum value. in the data. Data is a collection of all that, numbers. So range is the difference between the maximum value and the minimum value in the actually numerical data. Because now when we have data about colors, some say they like red, blue. Here we don't have range. So range applies only to data where it is numerical, not for blood groups and colors, favorite color or favorite food, something like that. The range is not applicable. So range is not applicable to every kind of data. So when it is numerical, yes, range is applicable. So range is a difference between the maximum value and minimum value in the data. Or sometimes it is the highest value and the lowest value. Anyways, so range is equal to maximum value, or you can even call it the highest value. Highest value. Maximum value minus minimum value. Minimum value. Lowest value. A range is the difference between the maximum value and the minimum value in the data. Now, range is very important because now you have so many numbers. In question number 3, we have 30 numbers. Now, from where should I start my class intervals? To 0 to 10, 10 to 20 like this? Or should I start from 100 to 200, 200 to 300? Or should I make it like 0 to like 50, 50 to 100? See, class intervals, there are so many choices to make class intervals. Now, how do you choose the size? How do you choose if you should go with 0 to 10, 10 to 20, or if you should go with 0 to 50, 50 to 100, or if you should go with 100 to 200, 200 to 300, or should you start directly from 1000, 1000 to 1500, 1500 to 2000? So from where to start? That is why we need range. That's why we should find the range. Now, children, tell me which is the highest value in the data in question number 3.
$212.
Thank you. Very good. And that's right. Very good. Minus the lowest value.
$114.
Correct. 114. 114. And what's the difference?
$98.
98 is a difference. 98 is a difference. Yeah, 98 is a difference. So now I'm sure we all understand why we need the range. So the smallest value in this data is 114. That means you don't want a class interval like 0 to 10. What will you do with 0 to 10? There is no number. There is no value between 0 and 10. In this data, the smallest value is 114. So you don't need 0 to 10, you don't need 0 to 20, or you don't need 0 to 50, or you don't need 50 to 100. Because the smallest value itself is, 114. So you need to start your class intervals only from 110, or you can even start from 114. See that again, there are different ways in which you can prepare the class intervals. You can do like 110 to 120, 120 to 113 because the class size should be 10, right? The class size is 10. And you should start with 110 because the smallest one is 114. So you don't need 100 to 110. You don't need this because even if you write this class interval, there is no value in the data that fits in this class interval. So you must start only from 110 to 120. Why 120? Because it's given the class size should be 10. And see here the class size is 10. 120 minus 110. Class size is 10. And I told you if nothing is mentioned, the class intervals must be continuous. So 120 to 130, 130 to 140. And like this, you will go on till what is the last class interval? What will be the last class interval?
$210 to $220, ma'am.
Very good, Madhumita. 210 to 220. This will be the last class interval because you don't need 220 to 230 because there is the highest value in this data is only 212. Biggest value you have here is 212. There is no value more than this. Then why will you need 220 to 230? There is no value that belongs to this class interval. That is the importance of finding the range. That is the importance of finding the range because range tells you. There is another thing, there is no time to, if I start that, it will take another 10 minutes. So I'll tell you the other thing about range in the next class. But one of it is that range tells you from where to start your class intervals and where to finish your class intervals. And the class size is given here, but otherwise you will have to decide the class size. That also we'll see in the next class, how to decide the class size. In this question, it's given the class size is 10. So you can go with this one. This is one way of doing 110 to 120, 120 to 130. See, when it is, making building frequency tables, there are choices. Like when you're designing your house or, you're doing your project work, there are different ways. You can present your project work in different ways, but you should satisfy the conditions or the guidelines given by your teacher. In the same way, frequency distribution, you can prepare it in a few ways, there is no one answer for this one in statistics. There's no one answer. You can choose this one, or you can start your class intervals from 114 also. 114 to 124, 124 to 134, 134 to 144. So then what will be the last class interval? Very good, Sindhu. Very good. 204 to 214. That will be the last class interval because the highest value is 212. 204 to 214 will be the last class interval. So you can even start from here. 104. So there is nothing like this is wrong, this is correct. There's nothing like that. The only specification in the question is that you must use class intervals of size 10. And yes, we have used class intervals of size 10. If they ask you to take the lower limit as, of the first class interval as 110, then you should use only this. Or if they say take the lower limit of the first class interval as 114, then you should go with this. Then there is only one answer. Otherwise, you have options to decide how your class intervals should look. So this is the importance of range. So you know from where to start the class intervals, where to finish the class intervals. The class size is given. If it is not given, how do you decide? Now, for example, will you make 110 to 160, 160 to 210? No, that means you're, or maybe say like you, supposing, for example, 100 to 200 and 200 to 300. Two class intervals are enough. No, all these numbers will fit into these two class intervals. If you make 100 to 200 as one class interval and 200 to 300 as another class interval, all these values from 114 to 212, they'll fit into these two class intervals. So what we should understand here is that the number of class intervals are very important. Depending on the data. So again, I cannot fix, you must have at least 5 class intervals or 6 class intervals. It depends on the data. Sometimes minimum class intervals can be 100 also. If the data is very huge, you will have more number of class intervals. If the data is small, you will have lesser number of class intervals. Now, for school children, now for our studies, minimum there should be like some 5-6 class intervals at least. There should be at least 5-6 class intervals. For school studies, I'm saying, like for us, At least 5-6 class intervals. What is, or supposing you make only one class interval, 100 to 300. All the numbers will come here only. So that is not the right way of representing the or organizing the data. It's like, you know, you have a bookshelf in which you have 5 to 6 compartments, but you shove all your books in one compartment. Then what is the point? You know, there are so many other spaces, no? So you can say, you know, like you can arrange your books like textbook in one compartment, workbooks in the other, classwork in one, homework in the other, tuition notebooks in one, something, or a dictionary in one. So you can spread it like that. If you put everything in one compartment, it's big, and you know all your books can be accommodated in one, and so you put everything there. So that's not the right way or the correct way of organizing your books. So like that here, if you say 100 to 300, just take one class interval and put all the numbers into this, then how will you study the data? If you organize it like this, so if you put all your books into one compartment in your shelf, it's so difficult to take out one book. If you want one book, you'll have to really disturb all the other books, and you know, or your bookshelf will become messy. But if you had put, you know, books in different compartments, textbooks in one, workbook in the other, classwork, homework, tuition notebook, and you know, dictionaries and things like that. So it's so easy. If you want the maths workbook, go to the workbook compartment and pull the maths workbook from there. So that is the benefit of organizing efficiently. Similarly here, you must not put all the numbers in one class interval. You must use a minimum of, you know, 4 to 5 class intervals. Again, see, that number depends on the vastness of the data. If the data is vast, you will have more class intervals. If the data is small, you cannot force, you know, many class intervals there. So then you may probably have some 4 to 5 class intervals. But having one class interval, 2 class intervals is not appropriate. 3 class intervals also no. At least 4, I can say. All right, children. So please finish the second one and try to do the third one. Try to do the third one. So the columns will be, first column is with the class intervals, second column will be tally marks, and the third column will be the frequency. So now that's how we are going to arrange the raw data in the form of a frequency table. All right, children, I've already taken 15 minutes extra. All right, children, so that's it for today's session. Thank you so much. Good night. You may leave the call.
Thank you, ma'am.
Thank you.
Thank you, children. Thank you. Good night.